In this video, what we're going to do is we're going to try to cover pointers and scope. And to do this, I'm going to try to give you an example of how the computer actually deals with memory. So I'm going to start off drawing a beautiful little picture here. And I apologize for my drawing. I'm still trying to get used to the drawing on a computer screen. So what we're going to do is we are going to pretend that I've given you the task of setting up memory and being able to address and store data at each place in memory. Now, most likely you're going to come back and you're going to do something like this. And you're going to say, well, if you tell me where to put something, I'll give you an address. And so what we're going to do is we're going to walk through this application that we have here, and we're going to look at scope first. We're going to try to make sure that you understand exactly what's going on with scope. So the first thing that we see here is that we declare an integer called I. So I tell you that I want you to give me a place to put I. And so you come back and you tell me, okay, put I at position 1, 2. Well, the first thing is that let's just for our example say that an integer takes up 3 places in memory. So you have told me 1, 2, so I'm going to go to position 1, 2, and I'm going to put my integer value in these 3 boxes. Okay? So at this point, we are calling a func1 function, and that is defined down here. We're passing it an integer value. So as soon as this function gets called, which is happening on the same line, the system is going to come out and say, okay, well, I need another position for another integer. Now you'll notice this integer is called I, and this integer is called I, but they're not the same thing. This has scope down here. This has scope up here. So you're going to come back and you're going to say I2. I want you to put that at position 2, 3. So I'm going to come down here and I'm going to say, okay, that's 2, 3. And so this integer value is going to be stored in these 3 boxes. Now, you're passing me a number 2. So right now, this integer value is holding a 2. So this position here has a 2 in it. This position up here has an unknown value because we haven't actually finished our function call. So remember, you've got to follow the code. The fact that I'm making a function call here means that I can't actually tell you what I is set to until this function returns. If we look here, we can see that the function is going to return an integer value. So the fact that this is an int and that's going to return an int, everything is good. So the first thing that happens here, once we get inside of here, is that we define another variable called p. So I'm going to come in and I'm going to say, okay, well, I need a position to put p. And so you come back and you say, well, put p at 4, 1. So I'm going to come down here to 4, 1, and I'm going to assign 3 boxes. And I'm going to say, well, p is equal to I. Well, what is I? Well, right now I'm looking at I1 because I up here doesn't have anything in it, and I'm scoped down here. So my I1 plus 1, I1 is set to 2, plus 1 is 3. So now we're going to set P equal to 3. The next thing we're going to do is we're going to set I to 23. Well, I is our local variable I. So that is this I2 that we have here. So now we are going to cross this out and we're setting that equal to 23. And then we're going to return P. Well, P right now is 3. It comes back up here to this function 1, and function 1 basically gets replaced with a number 3. And so now this variable up here is now holding a 3. So scope is very important, and hopefully you can see another downside to the way that this is happening at the moment, is that to make this one function call here, we actually had to define 3 different variables in 3 different places in memory. Now, once this returns out of the function, this P and the I2 disappear. So the values that they have will still be here, but the memory address is gone. It'll be reused. So returning out of the function automatically gets rid of those memories, those spots in memory where those variables are held. Now, it depends on the programming language as to whether or not those items are actually automatically freed or whether you have to free them. But in any event, you're going to have free memory once you leave here, because those variables only had scope up here. So if I were to come up here and say print P, it would tell me that P doesn't exist because P isn't defined in this particular function. Now, what I'm going to do real quick is I'm going to actually run this application. Get here. And so you can see that the first call is 3. So looking at our code up here, what this thing is actually doing is it says first call is equal to 3, and it passes in I, which is this guy up here, and it equals 3. Now, what I want to do now is I want to erase a few things on here real quick. And we want to change this code a little bit so that we're using pointers instead of the memory, instead of the variables. So we're going to modify this function just a little bit. So what I'm going to do is we're going to start by coming up here to our pre-definition of our function, and we're going to turn this into a pointer. And you do that by putting an asterisk after, and again, this is C code. All the different languages are a little different, but I'm turning that into a pointer. So that's basically saying that this is no longer an integer. It's actually a variable called I that points to a memory location. And you'll understand this a little bit more here in just a second. So I'm going to comment out these 2 lines of code, and we are going to get these lines here and put those back in. Now, what we are doing here, oh, and I got to change this and tell it to, we're going to receive a pointer, and we'll just do the same. We'll leave that code the way it was. So let's make sure that we can compile that. Pointer without a cast. Oh, that is down here. And I'll explain this in just a second. Let's see. I equals 23. Oh. Okay, so here's what's going on. We are going to come over here and let's get rid of what these things equal for just a second. Now, we're going to leave the values that we have here alone for just a minute, but what I want to do is I want to show you what is really happening here. So the first thing we do here is we define an integer value that is actually equal to 2. Now, this is our I, and we're just going to pretend that it's still pointing at 1, 2, and except that now we've gone ahead and defined it to equal 2. Then, just for example, we're going to declare another variable that is a pointer to an integer called j. Now, this value, this variable here is not pointing at an integer. It is actually pointing, it is containing an address. So what I have done is I've basically said that j is going to point to an integer type, but it itself is not an integer. It is an address. It's a pointer. And this is going to make more sense here in just a second. So now on this line, what I'm doing is I'm telling J that J is going to point not to 2, but it's going to point to the address of I. So down here in our list of variables, J is actually pointing to 1, 2. So this is J. J's pointing to 1, 2, and it knows it's an integer. So if you were to ask it for information about what it's pointing at, it could tell you, because it knows that it's pointing at 3 bytes and it needs to give you the data at that particular position. But J itself is a pointer. It's just an address. So the next thing that we did is we modified the function. So func1, instead of getting an integer, it actually receives a pointer now. Well, what does that mean? Well, what that means, if you remember up here, we had this I'm sorry. Let me erase this because we are not going to have. Earlier we had a variable that was actually got created when we called this function. We're not going to have a new variable now because we're passing the address of a variable that already exists. So we're passing in an address to I. So when we get down here to the function and start looking at what it's doing, we still declare, and we don't have to do this, but we declare another variable P. So here is our P, and it's still pointing at 4, 1. And this is a very important thing to understand. I up here, and it's called J up here, but again, these are both pointing, because they're pointers, no matter what they're called, they're still pointing to the same spot in memory. So nothing new got created when I called this function. But in order to get to the actual value that this pointer is pointing at, we have to do what's called dereferencing. And that's what we're doing when we put this asterisk in front of the variable. We're telling it, look, I don't want the address of that variable. I actually want to know what it's pointing at. And because it knows that it's a pointer to an integer, it can give you that data back very easily. So this line here is telling it, get me the value at position I. Well, position I is 1, 2, and its value is 2. So this is going to be a 2 plus 1. So now P, our local variable, is equal to 3. So just like before, we set P equal to 3. Then we dereference I again, and we say, look, again, whatever is at position I want to set it to 23. So up here, even though we have scope, and scope still applies, because I passed in the address of I instead of the actual value, we didn't create a new variable. We actually still have the variable I, but now it is going to equal 23. Because we dereferenced what it was pointing to. It was a 2, and we know that here because P is actually equal to 3 now. And then here we have told it that we want to actually change what it's pointing to a 23, and then we're going to return P. So one of the things that I want to change here is I want to come up here to where we call J, and we're going to actually set a new variable here, int k equals. What I want to do is I want to add K, and we're going to tell it to tell us what K is. So that's going to be what got returned by P. So what you're going to actually see here is that even though this variable here has scope inside this function, we are actually going to change the value of this variable up here because we passed its address into our function so that we could work with it directly. And I know this may be a little bit confusing. You may have to watch it a few times, but the pointers are actually very, very powerful if you learn how to use them and make some sense of them. I don't know why I keep doing this. Let's just do a ./test. So the first thing that we did is we printed out the address of J, and you saw this earlier. So this is actually printing the address of J. So that's its address. We then told the thing to call that function, and we told it to print out the value of I. Well, notice I is now 23, even though we didn't, we have scope of I inside of the main function. And then K, what got returned from P, is actually 3. So it's exactly like what we would expect it to be. So as an example, again, we have, just to kind of recap here, we have an integer set to 2 called I. We then declare a pointer that is going to point to I, to the address of I, and then we assign the address of I to J. So J is a pointer. We now changed our function down here. Let me get some of this goobly gah out of the way. So now we have changed our function down here to actually receive a pointer instead of a integer. So it's got an address that is being passed in here. Well, what address is being passed in? The address of J. What is J pointing to? J is pointing to I, which is a local variable up here in this function. We then do the same things we were doing earlier. We have to dereference the value of I so that we can get to its value. And then we dereference its value again and set it to 23. And then we return P, which is the same thing we were doing earlier. P comes back up here and sets K, and then K is printed last, and you saw it was 3. And then I is magically changed to 23 because we told it down here to change it to 23. This line here is actually telling it to change it to a value of 23. So the pointers give you the ability, instead of recreating variables all over every time we call a function, we can pass in a bunch of pointers, which are just addresses to those spots in memory, make whatever changes we want to make to them, and then when the function returns, we've actually modified whatever it is we needed to modify without passing any extra memory around. We're not creating memory and then destroying memory. We're actually just passing these pointers around. And this is one of the reasons that C is such a fast language, because you do have a lot of abilities that you don't have in other languages.